Hello. Today we're going to be looking at something called binomial probabilities and geometric probabilities. So, up to this point, we know about factorials, combinations, permutations, and how you can arrange things with identical objects. Well, today we're going to be using that idea of a combination because sometimes we don't care about just the total number of possibilities that we'll have. Sometimes we'll want to know the probability of getting a certain amount of successes out of a certain amount of trials, and that is called a binomial probability. So looking at our guided notes, we do have a formula for this. It is the binomial probability of R, or some number of successes, equals that NCR, which is that combination, times the probability of success to the total number of successes we want, times the probability of failure to the however many failures that will be. So let's look at the first example. In the first example, it says, privacy is a concern for many users of the internet. One survey showed that 59% of internet users are somewhat concerned about their confidentiality of their email. Based on this information, what is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their email? So there are 4 things I need to find. I need to know our N, which is our total number of trials. I need to know our R, which is how many successes we want. I need to know our P, which is a probability of success. I need to know my Q, which is a probability of failure. So reading through, I see sample of 10 internet users, so I know my N is 10. 6 is going to be our success. And then more towards the top, it says 59%. Well, as a decimal, that would be 0.59. And the way we can get our probability of failure, once again, is to take 1 minus the probability of success. Or in this case, 0.41. Okay. So now I'm going to plug all of this into our formula. So we have the probability of 6 successes equals, well, first was our combination. So combination using 10 trials, comma, 6. Remember, you type that in. Then we have the probability of success, so 0.59 to the 6th power times 0.41. And that exponent said n minus r, or in this case, 10 minus 6, which is 4. Okay, at this point in time, we can actually type it in our calculator. So, parenthesis, and to get the combination, remember we go to math, over to prob, and you want number 3, that NCR. Our N was 10, move over, our C is 6, we'll move over, parenthesis. And then it said parenthesis 0.59. And to get to the 6th power, we want to do this caret button underneath the clear. And then 6. And then on our calculators, we're going to need to move over so we're not dealing with an exponent anymore. Close parenthesis. And then parenthesis 0.41. Once again, caret times 4. Still move over. Close parenthesis. And we can hit enter. And we have 0.25, or a 25% chance of success. Go ahead and pause the video here and try example 2 on your own. All right, just like the other examples, we need to find our N, our P, and our Q. Okay, reading this problem, it says the probability of pulling the correct multiple choice question, meant to say, of selecting the correct multiple choice question, is 0.25. What is the probability that you get 7 questions correct out of 25 questions on a multiple choice test? Well, the 25 questions is our total number. 7 of them we want successful. The probability of success is at 0.25, meaning our probability of failure is 0.75. So the probability of our 7 successes, we're going to type in NCR, N is 25, C is 7. Times 0.25 to the 7th power times 0.75 to the 18th power. Typing in our calculator, we would end up getting 0.165 or 0.17%. Okay. Did you know, though, your calculator will actually do all of that for you. You do not need to go through and type in that whole entire chain every single time. So if you go in your calculator and the VARS button, which is right next to your clear, I'll go ahead second, and then that VARS button, and we want to go down, keep on going down until we get to something called Binomial PDF. We can enter. Unfortunately, with our calculators, it will actually ask you the number of trials, probability of success, and how many successes we want. So we can actually type in then, well, we had 25 trials. Probability of success was 0.25. And the number of successes we wanted was 7. Go down to paste, enter, enter again. There's our probability. Okay. So sometimes, though, we don't care how many successes we want. We want to know the probability of, well, when is our first success? So binomial probabilities deal with a certain amount of successes over a certain amount of trials. Geometric probabilities deal with when is our first success, or the probability of our first success. And here's our formula. N is still the number of successes, or number of trials. P is the probability of success. There is a special note, though, that the probability of success must be the same for each trial. So let's look at example 3. Example 3 says you are randomly guessing answers to multiple choice questions on a test. If there are only 4 possible answers, A, B, C, and D, what is the probability that your first correct answer is on the 5th question? So N and P. Our N in this case would be 5. We want it on the 5th. And our P, well, there's only one correct answer out of the 4, so 0.25. So in this problem, the probability of our 5th answer equals 0.25, which is that probability of success, times 0.75 to the 4th power, because 5 minus 1 is 4. Typing that in our calculator, we'll get 0.08, or an 8% chance. Pause the video and try example 4 by yourself. So we'll still need N and P in this problem. N would be the 9th pole, 9, and the probability of success is 0.2. The probability of the 9th being our success equals 0.2 times, well, 1 minus 0.2 would be 0.8 to the 8th power, and we should get 0.03. Let's look at some more examples. Example 5 says if you're randomly guessing what is the probability that you'll get 5 true-false questions correct out of 10. Now, I'm not looking for our first success here, so that tells me it's a binomial probability. So I will need my N, my R, my P, and my Q. Well, there are 16 questions. You want to get 5 of them. Probability of getting an answer correct is 0.5, or a 50% chance. Same with getting it wrong. Now we can do the same steps as using that formula. So remember, we go second vars, and we want to go down to binomial PDF. and enter. Total trials, there were 16. Probability of success is 0.5. And we want our success on the 5th. Paste, enter. Probability is 0.066 or 0.07. Now, example 6 is a little bit trickier. Example 6 says the probability that your name gets called to win an award is 0.36. What is the probability that you will be called at least twice out of 10? So, in order to do an at least problem, which is what is going to trip us up in it, is technically we need to do this problem multiple times. So, we need to do probability of being called one time and we need to do the probability of being called 2 times. Mr. Johnson takes that back. It needs to be 1 time and 0 times. So, N, R, P, and Q. Well, there are 10 times, and this time we want 1 being called once. Probability of success is 0.36. 1 minus that to get our non would be 0.64. Then we can type this in our calculator. Once again, second bars. Go down to Binomial PDF. Trials were 10. Probability of success was 0.36. And we want 1. Paste, hit enter, and we get 0.06. Okay, let's do it for 0. Still 10 trials. This time we want our R to be 0. Probability of success is 0.36. And failure is still the 0.64. And same as before. Second vars. Down to Binomial PDF. Enter. Still 10 trials. Still 36% chance of probability. We change our X to 0. Put down paste. And hit enter. And it's not 1 as a lot of you would think. It's actually 0.01. Now, to get our final answer, when we say at least twice, that means we could get it 2 times. 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. And we could have done the problem all of those times and add up all of our answers. Well, in this problem, it's quicker to do the 0 and 1 and take our two answers and subtract it from 1. 1 minus 0.06 minus 0.01. Typing it in the calculator, we should get 0.93. Okay. Example 7. The probability of having your name called to win a car is 0.8. What's the probability that you will be called on the third call? This doesn't say a certain amount of successes out of a certain amount of trials, so to me that means it is our geometric. So I need our n and I need our p. N, well, third call, probability of success is 0.8. So the probability of the third equals 0.8 times 0.2, or 1 minus 0.8 to the second power. Typing in our calculator, we get 0.03. Pause the video and try example 8. As you might have noticed in example 8, it is another geometric probability. We need our n, we need our p. N, well, we want it on the 8th question, so n equals 8. And probability of success. Well, I don't explicitly say it, but we know it is a standard multiple choice test. 1 out of the 4 answers is correct, so 0.25. Probability of the 8th being our answer equals 0.25 times 1 minus that to get 0.75 to the 7th power. Putting it in our calculator, 0.03. Go ahead, make sure your notes are complete, and try the assignment.